Our focus in this chapter will be on assembling and rigging LYON products. Other chapters of this startup guide include further information about LYON systems. Rigging and flying a LYON system requires the use of appropriate chain motors, wire rope, shackles, and additional rigging hardware not provided by Meyer Sound. All rigging hardware, including Meyer Sound equipment, needs to be used in accordance with local, state, federal, and industry regulations. All rigging hardware needs to be inspected for proper operation and potential damage before every use. In order to choose the appropriate sized motors, wire rope, shackles, and to conform to weight limitations of the structure, the entire weight of the array needs to be calculated. Meyer Sound's MapOnline XT software provides detailed weight information. Additional allowances need to be made for the weight of cabling, motors, and additional rigging hardware. The total weight, front and rear rigging point weights, and the center of gravity location are all provided within the flown loudspeaker system properties window. The safety limits analysis in MapXT is a valuable tool in designing systems and ensuring safe operation. MapOnline XT provides 5:1, 7:1, and BGV C1 safety factor status. If the array is too heavy, the load status will change. If the center of gravity is exceeded beyond the safety factor selected, the load status will also change. The MTG LYON grid can be attached in a forward or rearward orientation to shift the center of gravity for maximum up tilt or down tilt. 4 variables will change the center of gravity: the grid orientation, the grid angle of rotation, the number of loudspeakers, and the splay angles between them. There are 6 rigging points on the grid, 3 on the front of the grid, and 3 on the rear. The MTG LYON grid should only be attached to motors using a combination of these rigging points. The grid also has 4 openings for an inclinometer's laser beam to pass through, and 4 mounting points for the RPP LYON rear pull-up plate. These 8 openings are never used to suspend the array. Meyer Sound offers a laser bracket to facilitate mounting a ProSight inclinometer sensor and laser to the MTG LYON grid. There are many different mounting positions available on the grid. Using an inclinometer with a remote display increases the accuracy of trimming the top grid angle to match the MapOnline XT array design. The MTG LYON grid allows for a variety of rigging configurations. Using the center rigging points is common. When working with larger arrays, it is good practice to use 2 motors attached to the outer rigging points where the load is heavier, and to use the motor V-plate or a single motor attached to the center rigging point on the lighter load. The horizontal aim of the array can be adjusted plus or minus 22 degrees when the MVP motor V-plate is attached to the MTG LYON grid with 2 motors at either the rear center or the front center pickup points. There is a wraparound cover designed to accommodate the grid or a transition frame traveling on top of a LYON stack. LYON uses 2 different pins: red button pins for attaching to grids, and black button end frame pins, which are used in both the loudspeakers and the caster frames. LYON pins are 7/16 inches in diameter and smaller than the 1/2 inch diameter LYO pins. The LYON end frame pins are black in color to differentiate them from the blue buttoned LYO pins. Red pins for both LYON and LYO are used on the grids and have lanyards attached to them for mounting them to the grids and transition frames. Each LYON loudspeaker has 5 black button pins per side. On the end frame there are angle degree pin locations and locking pin locations that correspond to the available splay angles. The angles are selectable between 0.5 degrees and 9 degrees. The Guide-A-Link captive LYON rigging allows the loudspeaker splay angles to be preset before the array is assembled. The splay angles are adjusted using the front top link. The angle pin determines the distance the link can move vertically. When the system is lifted, the link extends. The locking pin is used to lock the link in its extended position. The rear link has 2 positions: retracted or stowed when not attached to another loudspeaker, or extended to join with the array. When the loudspeakers are transported, the lock pin is located in the 0-degree transport position, and another pin should be in any of the yellow angle positions. The top LYON in the stack will have the angle pin in the 7-degree position and the locking pin in the stow position. Now that the rigging hardware and its operation have been identified, here are the steps to assemble an array. Start by presetting the angles between the loudspeakers that were determined in the map design. Leave the top loudspeaker links retracted. The angles are preset by moving the angle pin to the desired splay angle position on both sides of each loudspeaker. Move the lock pin from the 0-degree transport position to the stow position in each loudspeaker. When the array is lifted, the loudspeakers will splay. For each loudspeaker, move the locking pin from the stow position to the locking position that corresponds to the angle selected. The locking pin prevents the splay angles of the array from compressing when the array is down-tilted. Using the appropriate rigging configuration for the application, attach the motors to the MTG LYON grid using 3/4-inch shackles. A short piece of wire rope or deck chain is usually attached between the grid and the motor to allow the chain bag to hang freely from the motor, so chain is collected in the bag without spilling. If the MVP V-plate is used, the connections to the motors and to the grid are made with 3/4-inch shackles. Attach the inclinometer to the grid. Attach a tape measure to the grid if it will be used to determine the trim height. A laser rangefinder can also be used. Attach the RPP LYON if used. There is a forward and rearward mounting position designated in the map design. From the map design, the grid orientation is determined. The forward grid position means the speakers are mounted toward the front of the grid. This can also be called the down tilt position because it shifts the center of gravity to allow the most down tilt of the grid. Here we see the grid in the rearward position. Always verify the correct position is being used before flying an array. To mate the grid to the top LYON, raise the grid. Move a stack of LYON underneath the grid. None of the rigging links of the top LYON should be extended. The angle pin should be in the 7-degree transport position. The lock pin should be in the stow position. The next instructions avoid pins being held while an adjustment is made. This will avoid pocketing or misplacing the pins. Every time a pin is removed, it is placed in a new position immediately. Lower the grid to within 2 inches of the stack of loudspeakers. Remove the red button pins from the grid. Remove the angle pin from the 7-degree position. Using the hex head knob, raise the link and insert the angle pin back in the 7-degree transport position. This extends the link and allows it to extend even further if needed for attaching to the grid. Attach the front links of the LYON to the grid using the red button pins. Lower the grid to rest on the top loudspeaker. Remove the rear link pin from the loudspeaker. Extend the rear link and replace the pin. Pin the rear links to the grid with the red button pins. Move the locking pin from the stow position to the 0-degree locking position. The angle pin remains in the 7-degree position. For the remaining loudspeakers, move the angle pin to the designated angle while the loudspeakers are stacked, prior to being flown. The locking pin should be in the stow position. When the array is floated and the loudspeakers have splayed, move the locking pin from the stow position to the corresponding locking position to lock the splay angle. Confirm that the angle pins and locking pins are properly set. The locking pin locations are always 3 holes directly below the angle pin location. Attach the cable pick and make the power and audio connections to the loudspeakers. The cable brackets are used as strain relief for cabling. They are not rated for any rigging use. Inspect the rigging elements to make sure they are taking tension without binding or twisting, and that they will not crush any cables as weight is taken. Confirm proper cable connections and make sure that there is enough slack to avoid excessive tension. To remove the caster frame, float the array, remove the front pins that attach the caster frame to the bottom of the array, lower the front of the caster frame and put the pins back in the loudspeaker. While holding the caster frame, take out the rear pins and lower the caster frame to the ground. Put the pins back in the loudspeaker. Raise the array high enough to roll the next stack of LYON in place. Lower the floating array to just above the next stack of loudspeakers. Remove the front bottom pins from the flown loudspeaker. Remove the angle pin. Using the hex head knob, lift the front links into the slots of the loudspeakers of the flown array. Insert the front bottom pin. Insert the angle pin in the designated position. Continue to lower the array so the loudspeakers rest on top of each other. Remove the rear bottom pin from the flown loudspeaker. Remove the rear link pin. Raise the rear link and insert both pins. Set all angles as before. All angle pins should be inserted into the proper angle pin locations with the locking pins still in the stow position. Confirm a total of 5 pins are visible on both sides of each loudspeaker. Following the same steps as with the previous loudspeaker stack, raise the motors and remove the caster frame. Again, the black button pins in the stow positions are now moved to the appropriate locking position. Continue using this method for the remaining loudspeakers. Here again are the basic steps. Move the angle pin to the desired location in the yellow area. Move the pin from the 0-degree transport position to the stow position. Float the stack of 4 loudspeakers. Move the locking pins in each loudspeaker from the stow position to the locking position in the blue area. Repeat this process as additional loudspeakers are added to the array. The optional PBF LYON pullback frame attaches to the bottom of an array and can be used with a motor rigged behind the array for extreme down tilt. The additional motor is rigged directly above the final trim position of the bottom speaker of the array. The pullback frame can also be used to expand the array's splay angles during assembly so the locking pins can be more easily inserted. For both uses, attach the pullback frame to the bottom of the array using the 2 rear pins. Attach the pullback frame to the motor using a bridle at least 25 inches long with either 5/8 or 1/2 inch shackles. When using the PBF to expand the splay angles at the bottom of a long array, and an additional rigging point is not available, the RPP LYON rear pickup plate can be used. The RPP is mounted to the grid using 2 pins, 1/2 inch in diameter and 2.5 inches in length. Attach a 1/4 ton motor to the RPP, hooked down with a 5/8 or 1/2 inch shackle. The motor is then attached to the bridle of the pullback frame using a 5/8 or 1/2 inch shackle. The motor will lift the bottom speakers, extending the front links and aligning the locking pin holes. Only a 1/4 ton motor should be attached to an RPP LYON. An excessive compression load could be generated in the array if a larger motor is used. Once the locking pins are inserted, relieve the tension of the 1/4 ton motor attached to the RPP LYON. Before trimming the system, check that the cable pick will not tangle as the array is lifted. Raise the array to the designated trim height. The distance to base value within the flown loudspeaker system properties window in MAP is the distance from y = 0 to the bottommost point of the array. This can be used to determine the trim height of the array. If using a V-plate, make adjustments to the panning of the array before adjusting the grid angle. When the approximate trim height is reached, use the up and down stage motors to set the angle of the top grid using the inclinometer. When the grid angle is set, use both motors at the same time to finalize the trim height adjustment. Verify the grid angle once more. LYON can also be used as a downfill element of a LYO array. The MTF LYO LYON transition frame is attached to the top LYON loudspeaker. The transition frame is then attached to the bottom LYO loudspeaker in the array. De-rigging the system begins with equalizing the weight load of the V-plate motors if a V-plate is used. Ensure the cable pick has enough slack to allow the array to travel down to working height. Decrease the trim height to working height. Disconnect the cabling from the loudspeakers. Move the locking pins to the stow position. If the pullback frame is used, run the motor down to allow the angles of the loudspeakers to collapse. Remove the pullback frame if used. Locate a caster frame under the array. Lift either the front or rear of the caster frame and pin it in place. Lift the other side of the caster frame and pin it in place. Land the array. Disconnect the front links of the top loudspeaker of the group to be removed. Disconnect the rear links of the same loudspeaker. For the top loudspeaker, move the angle pin to the 7-degree position. The locking pin stays in the stow position. For the other loudspeakers, move the pin from the stow position to the 0-degree transport position. The angle pin does not need to be moved. Cover the loudspeakers. Repeat this process for each group of loudspeakers. The grid can travel on top of the last group of loudspeakers. The MTF LYO LYON transition frame can ride on top of a LYON loudspeaker stack. This is the basic array assembly and rigging information for a LYON system. For more information, refer to the MTG LYON Assembly Guide available at meyersound.com.